Hey, g'day, it's President. Thanks for stopping by. Now, this is episode 3 of building a ThreadExpress version 3. Now, ThreadExpress is a thread milling attachment that fits onto a knee mill or a horizontal mill like a Cincinnati, and it allows you to thread mill using your existing milling machine and a simple fly cutter. Now, it's not my invention. It belongs to a toolmaker in New Zealand named Cliff Hall. And I'll put a link up above there now to his YouTube channel, which is called ThreadExpress, and you can jump over there and have a look at the way he is slowly revealing the design for this machine. Now, in fact, he is going to reveal all of the mechanism, and you can have a look at that and see how it operates. But what I'm doing is building a replica, or an updated replica, which we're calling version 3. Now, in today's episode, I want to do the rest of the operations on this spindle here. Now, the spindle of ThreadExpress carries a chuck, either a 3-jaw chuck or a Ep.3 collet chuck to allow you to hold workpieces in it. And this 7 TPI 1.25" thread here also forms a lead screw. And a nut is able to run up and down that lead screw there. It's going to be machined from this piece of bronze hollow bar. But what we have to do today is to drill a hole all the way through this spindle. That's what this big long series drill bit is for, and there are some threads to be cut on either end and a taper in the end of the spindle here for Ep.3 collets, and that pretty much finishes off that part of the build. But yeah, let's go over to the lathe now, and I think we're going to do all of the operations on the spindle and get that up to date. Okay, that looks good, so we'll just keep going. Okay, I think that's good. Let's give that a clean up with some Scotch-Brite. Then I'm going to put a fixed steady on the lathe bearing on this section here. I'm going to try to drill at least part the way up the end of the spindle. So I'm going to drill undersize and bore out to 18 diameter, and that will guide the drill bit through from the other end later on, I hope. I've bolted down the fixed steady. I've left the tailstock engaged in the center on the end of the part here, and I've set the fingers against that bearing surface, so when I remove the tailstock center, it should keep everything aligned, and then I go ahead and try and drill out at least part of this end of the stock. Alright, it's getting quite hot. I think I'm going to remove this section at the end here. I don't need that anymore, so I get rid of that. That's drilled 16 diameter, and then I'll open that up to 18 with a boring bar, so I get a sort of an accurate bore that's concentric with the rest of the part, and then I can flip it around and drill from the other end, and if necessary I can come back and still support that with the tailstock center. So I'll get rid of this bit, and then we just need to let the part cool down a bit. I think I'm starting to find the limits of this homemade fixed steady. If you get these fingers too loose, you get chatter. If they're too tight, it starts to wear and rub and squeak no matter how much oil you put on it. These are bronze tips on the end of the fingers there, and I've never done a job like this before with this particular tool, so I'm getting a bit nervous now about doing any more from this end. But I have got to open this up to 18, so I think I'll just do that, just break the edges and then flip it around. Squeaky, squeaky. All right, flip it. So I'll just check the pitch on that one. That's good. Okay, I think that's it. I'll just polish off the tops of the threads there, and then we've got to get stuck into boring out this end. Right, chuck backplate is not quite as tight, but it's got a register in the back of it and it will sit up hard against the shoulder as well. So I think it's going to be okay. Okay, well this is the part where I start to get really nervous because I'm on the second to last operation now, so I've got to drill through the entire spindle. I'm not even sure if I've got enough reach in my tailstock to be able to do that. I don't think I can get the tailstock back far enough. But I'm going to go ahead and drill as deep as I can, see if I can make it through. Yeah, let's just hope that my fix steady is up to it. Now, I don't know, are you meant to use oil or grease? Let me know in the comments. I'm using oil. Alright, changed drill bit, so I can't go any deeper with that one. Alright, I'm going to let everything cool down a bit, but the plan is to go as deep as I can with this Morse taper bit, and then I'll see if I can get the other long series bit into the tailstock. But I'm going to have to push that 18mm drill right through without a pilot hole, so that's going to be fun. Alright, had another go at that. I've gone about 100mm from this end. I probably only went about 60 from the other end. So I reckon I've got about 60 or 70 in the middle that needs to come out. So I'm going to have to swap over to that long series drill. Let me do that. It may or may not work. Wait and see. Okay, there's pretty much an overhead view, and I've got the tailstock here all the way back on the bed. I could probably go another 10 or 20mm, and I can just get the drill bit into the hole, but can I? Yeah. So that will go in, and I've got clearance here, but I wouldn't be able to withdraw the drill bit to clear the flutes. So I think the only solution here is to cut the drill bit off short, and I think I can do it. But I'm going to have to sacrifice the end of this drill bit, but it was a cheap one I bought from AliExpress anyway. Alright, I'll get back to you. Okay, that works. So I've got about 30mm clearance so I can get the drill bit out of the bore there. Clear the chips. So we'll just take it nice and slow. Oh, thought I was never going to get there. I've actually hit the 16mm hole at the other end, and I didn't bore all the way up from the other end at 18mm, so it sort of feels like it's concentric, but I'll keep going. I don't think I can set it up easily to drill from the other end, so we'll do a bit more and then we should feel the drill bit go all the way through. Oh, hallelujah. Tell you what, got newfound respect for my DIY steady. It performed really well then. So what we need to do now is to bore out the tapered bore for the collets. So that's the last operation. So as long as I don't screw that up, we're golden. Last job on the spindle is to bore out this end here for the Ep.3 collets. Now, just in case I'm confusing you, I have previously called this Ep.25. It's Ep.32, and the reason for that is because the opening to the tapered bore is 32mm right on the very outside surface here. So in order to get that dimension correct, what I've done is I've partially bored inside the drilled hole, and I've measured that diameter. Now it works out to be 18.46. So I have worked out the difference between that diameter and the finished diameter, and it means moving my boring tool bit 8.77mm in the radius. So I've already set my compound slider over to 8 degrees, and the final piece of the puzzle here is just touch the tool bit up against this end face, and then that becomes my 0 point in Z. So I'm going to do all of that and we'll bore that out. I've got to break this sharp edge up here, and then I can take this out of the lathe for good, I hope, until I lap it. Alright, so we just bump the tool bit up very, very carefully against that end face there. We're going to 0 in Z, and as long as I start from that 0 position, in fact I'll lock the carriage, and then keep boring until we get to 8.77 in the radius, and we should be good. So yeah, let me do that. Okay, lock the saddle. And we can come back to our 0 point. And that should be right on the corner of that bore. Right. Okay, that seems to be going okay, but I just realised I made a mistake with my mathematics, so I had put down the diameter of the opening at 36 instead of 32, so I just got to recalculate that. Still a way off, so it should be fine. I'll bring it back when I'm nearly done. Okay, I'm just about to do the last cut and then a spring pass. Now, just about everything that could go wrong did go wrong. I ran out of travel on my boring bar and had to extend it, had to do all the setup again. But I think I've got back to where I was, at least in terms of my starting position. So yeah, this last cut's going to be about 0.3 of a millimetre deep, and then I'll just sort of run it back really slowly as a spring pass. But yeah, I've got a bit of chatter come back as well. Alright, that looks legit. I'm just going to do some clean up here with a bit of emery on this end, and I think we're done. Yeah, that's good. That's closing up completely. Just getting ready to machine the counterbore in the back of this chuck backplate. So this is the backplate for the 100mm chuck or 4-inch chuck that can screw onto the top of the ThreadExpress spindle. So this section here, the plain unthreaded portion, has to pull up tight inside that threaded bore there. So 40mm diameter, 5.5mm deep, and this is all about concentricity. Everything about this spindle that I've made so far, it's really important that you get everything sort of concentric with the axis of that spindle. Okay, this little part here is going to be the split nut that is going to tighten up the two angular contact bearings. Now, just did this in the lathe, fairly simple part. Single point threaded a 25mm by 1.5mm thread on the inside bore there, and that screws onto the mating thread that's on the bottom of the spindle. Now, at present, it's a slightly loose-ish fit, but that's all going to get rectified when we split the nut and we can compress it onto that thread. So once we've got the spindle running in the angular contact bearings the way we want it, we just nip up the screw in this nut here, and that will lock that nut and keep the contact between the two bearings consistent. So what we need to do now is put a pair of holes in this face here so we can tighten the nut with a pin spanner, and then later on we'll split it, put the thread in it. So we'll do this now. I'll show you how I'm going to set this up using my little touch probe and touch DRO. So I'm just going to drop this into a V block, and it's sitting on two parallels, and I've got a spring in between the parallels, keep everything sort of sitting where it is. And this doesn't need to be really tight because we're only drilling two very small holes. So I'll just make sure that's seated down on the parallels. Nip that up. Now this is an awkward thing. We've got to get the spindle of the milling machine directly over the centre of this part here. So I've already measured it. It's exactly 40mm diameter. So I'm going to touch off against the back face of the vise and then come forward exactly 20. That will be over the centre in Y, and then we just got to find the centre in X. So with touch DRO, you can touch off against the inside of a part or the outside of a part. So we'll do this now. I'm just going to touch off against this jaw. Alright, so we're going to touch that jaw 3 times. That's 1, 2, 3, and touch DRO averages those 3 contacts. So we set origin, and then move exactly 20. Alright, that puts me over the centre in Y, and now we're going to touch off against the two outside edges of the part and centre that to get the exact centre. Okay, it's the first one. Okay, and set origin there, and then we can wind back to the exact centre. Now I don't really need to go to the exact centre. What I need to do is to go to the two hole centres, and they're 16 millimetres either side of this centre of this particular part. So we'll do that. We'll set that to 16, and that's there. So we'll lock the table. So I'm just going to centre drill or spot drill, and then two 3 millimetre holes. Okay, so now we can use our pin spanner to tighten this up later. So now we're going to reset and put this space vertical in the vise and index against those two holes so we can do the rest of the features. Alright, this is the setup that I've come up with. So I've got two 3 millimetre dowel pins in the holes we just drilled, and I'm using this 1, 2, 3 block both to clamp the part against the back of the vise here, but also it allows me to register those two pins and keep them vertical. Now I've just realised that I didn't make any provision for a slit on the other side of this ring here. So there's a chance that the socket head screw won't be able to close that enough to pinch down on the thread. But if that's an issue, I'll just have to set it up again. Alright, just hit my first issue there, run out of travel on that 6 millimetre end mill. I actually don't have the correct end mill, which is a 7 millimetre. I've got a 7.5, but it's not a centre cutting end mill. So I'll just have to extend this one a bit more and try to get down to the depth that I need. And then, yeah, we'll follow up with this one just to bring it out to the correct diameter. There's always an issue. Alright, well there's our seat for the head of the screw, so I'll go ahead and do that. Just got to be a bit careful when I drill the clearance hole to make sure I only go through just past halfway. I'll finish that thread off later. Okay, I've got a 1.5 millimetre slitting saw and an arbor there, and I've got some feeler gauge stock on top of the part. We'll just bring that down, trap the feeler gauge stock, and we'll set our Z to 0 there. And then you just got to offset by half the thickness of the slitting saw and the radius of the part. And if you want to, you can account for the feeler gauge stock, but it's not really that big a deal. Okay, I'm an idiot. Forgot to turn the camera on. I've already made the cut. No big deal. But what we'll do now is finish the thread off in here, and then we'll see if it will close up on the spindle. So, did it actually work? Well, mercifully, yes it did. So we can wind the nut onto the thread on the end of the shaft there, and we can tighten down on that socket head screw. And you don't have to go overboard. It's still rotating. You can sort of feel when it tightens up. So that's locked solid now, and we can put our pin spanner in there later on to tighten up that nut against the two angular contact bearings. And once we've got everything set, we just lock that in place and that'll never move. Got this set up in the 4-jaw chuck. I've dialed it in on the face and on the outer perimeter. So I'm going to bore this out to 25, but I'll start with a 22 drill. Good, I'll take that. Now I've got to clean up this outside diameter. This material was induction hardened when I got it, and I did anneal it in the oven, but I didn't actually fully anneal it, so it's still a bit tough. I think I need to swap out to a different insert here. Alright, I just tried that with a bigger insert and it's awful. That's way harder than I expected it to be. When I checked the outside skin with a file, it seems soft, but then it's sort of super hard underneath that. So I may have to fully anneal this. Don't want to, because I'll have to change the setup. But I don't think I'm going to get anywhere with these inserts. I'll get back to you. Okay, I couldn't think of what else to do here, so what I'm going to try and do is fully anneal the gear, and to protect the teeth of the gear from oxidizing, I've made a sort of a stainless steel ring to go around that and cinched that up with wire, and I've got some brazing flux that I mixed up with water, and we're just going to stick that on there and hope that that protects the surface from oxide. And essentially when you're brazing metal, that's what you're doing anyway. Now it may or may not work. Even if it doesn't work and we get some oxide on these teeth, I don't think it's going to matter. Now this is going to ruin today's video. I was hoping to finish up with showing you how this all fitted, and I think we're going to run over our half-hour limit, so I'm going to try to show you what I'm doing here with the annealing, and then we might have to cut it and carry on in the next video. And don't forget that Christmas is coming up and everything shuts down for Christmas, doesn't it? You know, try and get in to see a doctor or get a plumber out anywhere 2 weeks either side of Christmas and New Year, and you've got no chance. So let me just stick this on and then we'll heat the furnace up. I'm just going to use my metal casting furnace, and I'm going to use the propane burner just so it doesn't get too hot. We just want to get this up to a good red heat and then let it soak for a little while, and then just leave it in the furnace to cool down. Alright, so I'm hoping that it's going to form a sort of a glassy surface over the gear teeth and protect them. Only one way to find out. Alright, let's put it in the furnace. I put a fire brick on top of the plinth, and I put some of that borax paste on the inside of the bore as well that we just machined to try and protect that. And that way the part is up out of the way of the flame. It's not got direct contact with the flame. So we're just using the circulating heat. So I'll get that lit up, and I think it's going to take about 45 minutes. But it will have to sit in the furnace overnight to cool down really slowly. Alright, I'm going to let that sit in the furnace for about, well, I'll leave it overnight probably. Took a lot longer than I thought to get it up to that temperature. The old propane burner that I'm using in this furnace is configured differently now because I changed over to a diesel fired burner, and it was sort of burning a bit sooty, but it's nice and hot, so I'm just going to let that sit there, and I'll check it tomorrow. Well, it's actually about 6 hours later. I didn't leave it overnight. That's cooled down enough now to handle, and you see how the flux is fused over that surface. So I'm going to take this out, see if I can scrub off that flux with a wire brush, If not, I'll have to boil it in water. Alright, let's see how this looks. Well, the outer edge is nice and clean. I'll give this a wire brush though. Yeah, that's not coming off. Okay, I'm going to boil this in water. Well, my induction cooktop decided to give up the ghost, but I put it back on the old-fashioned electric hot plate, and that's been sitting there for about 10 minutes, and I put some vinegar in the water as well. And I think that's done the trick. So I'm going to take this out and rinse it. We'll give it another scrub with the wire brush. I'll set it up in the lathe and take a cut on the outside just to see if it's soft enough. You can see that's done its job really well. That area that was covered by the flux is beautifully shiny. Now all of this interior part needs to be machined. The only part that's not really machined is just the outer edge of these teeth here, and they're still bright and shiny and they haven't oxidized, so I think that's good. Yep, so all of that flux is gone now. Yay, it's worked. Okay, I'm going to set this up again. Okay, I've set that up and dialed it in again. I'm going to try high-speed steel, and if my process is correct, there shouldn't be a problem. Well, that seems to have worked. I doubt that this tool would have touched that in its previous state. So this has got to finish at just under 86 millimeters, so there's about a millimeter to go. I'll do that off camera. I'll do some of the machining in the center. I'll show you what it looks like on the bench, and then yeah, that's it for today. Well, there's the bevel gear machined all over now. I must say that this steel was still fairly tough even though I had annealed it, but I got it all done with high-speed steel, so it was soft enough to do that. Now if you're wondering why these gear teeth are so narrow, it's because the nut and the nut carrier assembly has to fit right down against the face of that gear there. And if I left the teeth at their full width, there'd be a clash and it would limit the travel of the nut on the spindle here. So that's why there's very little of the teeth left. But that's enough. Remember, we're not running this at high speed. There's no high loads. It's all hand cranked. So this will do the job, which is to rotate that spindle. Now there is a gap there at the moment. Even though I've done that split nut up tight, you can see how the bearing can slide up and down there. But that's because we haven't fitted the bearing housing yet. So this needs to be machined out to fit the outside diameter of the bearing. It needs to go deeper as well, and that will get trapped in between the bearing and the bevel gear, and then the split nut will take up the difference. Alrighty, so that's all I'm going to get done today. Now I'm not going to leave you with any wildlife today because I want to put out a sort of best of 2024 clip in the next couple of days. So I'm going to show you all of the projects that I worked on this year and all of the wildlife that we've seen in the garden, and I'll have a bit more to say about thanking the audience and also about why I'm actually putting these wildlife clips into the videos. But we'll do that next time. So for now, it's Prezzo signing out. I'll see you next time. Cheers.